Hi, my name is Parisa, and here we are again this week with another video. And today I will be talking about B and T cells. So B cells, which are bone marrow cells, and T cells, the thymus cells, participate in the immune response. B cells originate from the bone marrow, and they mature there as well. Here, the cells are able to develop immunocompetence so they can recognize foreign bodies and differentiate between self and non-self tissues. B lymphocytes have around 10,000 proteins on their surface, which are the membrane-bound antibodies. Although each B cell has these proteins, each cell has a different unique set. After maturation, B cells reside in the secondary lymphoid areas such as lymph nodes. During this time, they are still naive until they come into contact with their specific antigen. The B cells are then able to replicate with the appropriate antibodies to fight off the specified antigen. These cells then become memory and effector cells. T lymphocytes, located within cells, act as the last line of defense by causing inflammation, activating macrophages, corresponding with other T cells, and regulating the majority of the immune response. After T cells recognize an antigen from the APCs, they replicate and also form memory and effector cells. Effector T cells, that is. T cells communicate through the release of cytokines, which they initiate more replication. After T cells have recognized infected host cells through MC1 proteins, they're able to kill those infected hosts, the host cells, and they do that by triggering apoptosis. So it's actually a lot of hereditary type of conditions and other syndromes that cause deficiencies in these cells. B cells, they function after recognizing antigens. However, they become more prone to bacterial infections if they are deficient. B cells can be deficient for a few reasons, one of which is the lack of maturation of B cells. IgA deficiency is another type of B cell defect. Such deficiencies affect B cell differentiation and even antibody production. The T cell deficiencies are mostly related to cell signaling defects. Pathogens of concern for deficient T cells are intracellular pathogens such as Salmonella. Most intracellular pathogens happen to be viruses, which causes the host with T cell deficiencies to be more prone to viral infections. Immunodeficiencies such as AIDS, for example, specifically attacks helper T cells, which limits the humoral response. This is important for B cells because naive B cells have to be inspected by the helper T cells, which can release cytokines to activate the B cells. This acts as a safeguard of the immune system so it doesn't overcompensate during an immune response. And it's important because it allows host cells to communicate to distinguish from self and non-self tissues, and this prevents damage to the host. Multiple sclerosis and type 1 diabetes are also common examples of autoimmune diseases. Thank you.